Good afternoon, everyone, and welcome to the Parsons Technical Webinar Series. I'm your host, Jessica Bennett. Today we have with us Tim Ulty presenting on Constructing a Digital World, the benefits of digital twins and how to build them. A few housekeeping items up front. We'll keep all phone lines muted throughout the presentation to keep any background noise down. If you have any questions throughout the webinar, you can either enter them into the chat feature at any time and we'll answer them at the end, or you can hold your question if you want to ask it live during the Q&A session. This webinar has been approved for 1 PDH credit. If you'd like to get that professional development hour credit certificate, you can complete the attendance form that has 4 multiple choice questions that you'll need to answer. We'll also post that link and those questions in the chat. If you have any issues accessing that, please let us know and we can get that to you after the webinar. And finally, this webinar is being recorded and will be available on the Parsons YouTube channel in the next few weeks. So a brief agenda, I'll introduce our guest speaker, followed by a core value moment, then the technical presentation, and then we'll wrap up at the end with Q&A. So Tim is a project manager and technical lead at Parsons X, our innovation hub that delivers cutting-edge technical solutions for architecture, engineering, and construction customers. He's currently involved in projects in both the US and the Middle East, and he's also managing spatial data for environmental and infrastructure projects. He is a member of the Parsons Drone Operations Team and Governance Board, and he's also an FAA certified drone pilot. He has a bachelor's in geography from Syracuse University and a master's in GIS from Penn State. And with that, I'll turn it over to Tim for the core value moment.
All right, thanks a lot, Jess. So at Parsons, we always like to start our meetings and presentations with a core value moment, where we highlight one of Parsons' 6 core values. And today I'd like to highlight the core value of safety. Specifically, the hierarchy of controls is a diagram that shows the preference of safety measures from the most preferable to the least preferable, PPE being the least preferable on the left. And I really want to highlight the value of elimination. I think it's something that sometimes is overlooked. We think of mitigating hazards, and kind of a more lighthearted example potentially is the comic on the right. You could mitigate a lightning storm. You could wear rubber shoes. You could try not to stand near tall objects. You could do administrative controls and rotate how long you're outside with someone else if you were working. But really, the preferable option is just not to be out in a thunderstorm. And this has applications for a lot of our day-to-day work as well. So, digital twins, for instance, some of the live feeds and scheduling asset inspections that can be done by a digital twin can eliminate some unnecessary field work. And that in turn can reduce risk, especially if some of the field work involves, say, inspecting assets at heights or hazardous assets such as those that are highly electrified. Another example would be like drone inspections. Something that we can all kind of wrap our heads around and make sense to us is that if you have someone inspecting the side of a high altitude bridge or the roof of a building, and you can do at least the initial assessment with a drone, you're completely eliminating the need to have people work at heights, which then reduces the risk to safety. And so with that, I'm going to get started. So my webinar today is on constructing a digital twin or a digital world, benefits of digital twins and how to build them. So the first question most people might ask is, what is a digital twin? The definition from the Digital Twin Consortium is that a digital twin is a virtual representation of real-world entities and processes synchronized at a specified frequency and fidelity. So what does that really mean? It means that, simply put, a digital twin is a virtual representation, so essentially a model with additional assets of real-world assets and occurrences that's regularly updated and therefore helps inform decision-making in a way that a simple model may not. And so related to that, you often have the question of what is not a digital twin. I've been to a lot of conferences. It's kind of it's a popular buzzword. So you hear a lot of people presenting on their digital twin. I'm a little less concerned than some people are and kind of gatekeeping what is and isn't a digital twin, but it is helpful to have a shared definition. And so something that is, just an asset management system or a 3D measure point cloud, BIM model, or a GIS base map, these are all can be tremendously valuable for their uses. And so on the right, you do have examples of both of these are drone-based 3D models. The upper one is a landfill. The bottom one is from a flood hardening project for critical infrastructure that we did. And so these in and of themselves are very valuable. They're a snapshot in time. They have some information embedded into it, such as location, color in this case, with each pixel, but they're not a digital twin. Like they don't update themselves. They're not connected to any other data sources. Valuable, but limited to what they are. So why should you build a digital twin? Well, asset lifecycle management, management oversight, and historic and predictive analytics. And so if we dig into some of those, we start with improved asset lifecycle management. So digital twins allow you to track the design, maintenance, and cost over the lifecycle of an asset. This includes not only tracking the installation of the asset, but also work orders and regular maintenance that are done on those assets. So on the example you see on the right, it's a relatively simple example, but still very, very clear that it's showing on a single easy to use interface work orders that are being done, in this case on a runway. And you're seeing, you can filter it by status, you can filter it by date, and you can see, how often is, say, a certain asset being worked on, and what is the status of that asset and how much is it costing you over the course of an asset, because as we all know, there's a lot more than just the initial purchase of an asset. The second thing, and this is one that is kind of dear to me, is the idea of democratizing institutional knowledge. What I like to sometimes jokingly call the hit by a bus scenario, where on many facilities, especially very advanced or complex facilities and sites, you may have people who are incredibly experienced. They're both specialists in their field, and maybe they've been there a long time, and they really know how a system works or individual assets. But if that person is on sick leave or, jokingly, as I said, hit by a bus, what do? So you say, well, where is that electrical panel? Well, John knows because he manages that and what it's connected to. Well, what if John gets hit by a bus? Well, then no one really knows where it is, and no one really knows how to maintain it. So the idea is to get that institutional knowledge unlocked from an individual and systematize it. And this isn't just constrained to the individual. You also have the scenario where you have institutional knowledge that may be shared across individuals, but still within, say, one discipline or one department. So you may have the maintenance team that knows a lot about the interconnection of assets, but then the actual team that manages other parts of the facility may not be able to draw any value from that knowledge that the maintenance team has. And so if you get that all into one system, it becomes much more utilizable across different disciplines. And of course, you can assign not only the location, but also attribute information to assets. So you might have the manual at a click. You can have who installed it, who's responsible for maintaining it with contact information. And once again, it just makes it a lot easier for people to do their work, because you can both be there at the asset and look up this information, but you can also be remote and look up if something has an issue with it. You can very immediately identify what the issue is without having to drill down to the individual software as used by each discipline that maintains that individual asset. And so digital twins, one of the key things about them is that they are almost always an integration of systems. They may be standalone software, but they are almost never maintaining all of their own data, or at least all of the data doesn't originate with the digital twin. It brings disparate systems together, often through the common denominator of location. So clients have distributed information from various sources. They may have design and construction data from BIM and from CAD. They may have asset information that is managed by an asset management system. It may be managed in an enterprise GIS system and database. You could have also document management, that tracks snapshots of project deliverables. And you also have clients that have real-time information coming in, increasingly so, from things like environmental monitoring, IoT sensors, scheduling information, logistics, supply chain, financial and costing information. The list goes on. And you have all of this very valuable information that your organization is collecting, but it tends to be locked in these silos. And each of these repositories or databases, or maybe even a set of databases, often has its own preferred data store, standard, and applications that let people access that information. But it's not very accessible to someone else. And maybe more importantly, it doesn't allow you to draw holistic insights by combining this data. So, there may be insights that you can only get by seeing, say, your GIS and your BIM and your scheduling information all together to really understand how they interconnect. And the way that many of our systems are currently set up, it doesn't really allow for that. You'd have to go talk to a GIS specialist, go talk to a BIM specialist, go talk to someone who manages your Primavera or your scheduling software. And so what a digital twin can do is that it can essentially act as your common data environment or your CDE that combines these various data sources together and makes it much more utilizable to you. And you can actually make use of your data from a higher level and from other departments where that data was just inaccessible before. And this is essentially a mock-up rendition of what something like this can look like, where you have these various systems integrated together to provide management and individual teams what is a common phrase in the industry is a single source of truth, or a single pane of glass is another phrase you'll hear more focused on, say, dashboards and interfaces that show that single source of truth information. The idea, once again, being that you're drawing the authoritative information from these sources, and ideally, you're not even copying it, because once you copy data, unless you have a live integration, you can become out of date quite quickly. And so ideally, you want to reference these data sets where they live, where they are authoritative, and draw directly from that so that you have some level of confidence that what you're looking at when you're making decisions, when you're running real-time analytics and creating reports, is the authoritative data that you want to be using. And last, for benefits of digital twins, you can look at historic data, and that often allows you to do predictive analytics and to look into the future in multiple ways. So one, it's very difficult to predict the future, of course, but one of the best tools you have is what has happened in the past. So if you can track your asset usage, the cost, the maintenance associated with that, the lifespan and life cycle of these various assets, that allows you to get a good idea of what to expect in the future. This could especially be true for things that may not be obviously apparent until you see them in a system like this. So you could imagine, a wastewater network where you may have various interceptors across the network or various pipes and pumps across the network. And you may have two interceptors that are basically identical, yet one needs 3 times as much maintenance as the other does. It wouldn't be something that would be apparent to you just by look, because they're the same interceptor, they maybe have similar flows, but they may have very different constituents that are feeding them wastewater. And so understanding that can allow you to begin predicting what your costs and maintenance needs are going to be in the future. And once you have that, you can then begin to model incidents and system changes before they happen. So, what if I double the number of passengers in a queue? What if I take an air handler offline? What are the effects of that on my system? And you can start seeing that once you have enough historic data to have seen similar incidents in the past. And very related to that need is the power to build relationships between assets. It's really a key feature of most digital twins, is the idea that, as you can see in the diagram on the left, you not only have the 3D model, of the individual asset and where it sits in space, but you also have these relationship graphs that are built between assets. So you can see, okay, well, this water heater is connected to this circulating pump, is connected to, and it's fed by this motorized valve, maybe fed by this panel. You can start seeing these interrelationships between assets so that you have a much better understanding of what are the impacts if one goes out of service for maintenance, one gets replaced, one gets upgraded, one gets removed. And lastly, on these relationships, it's not just about the things that, say, feed electricity or hot water or gas to each other. You also have location information and location relationships that can be valuable as well. So you may have an asset that you know about, but that asset is potentially located in a cabinet. That cabinet is located in a room. That room is located on a floor, and that floor is located in a building. And so understanding all those cascading relationships of location and interconnection really provides you much more insight into your assets that you would not have before. And so with those benefits, you've looked at this, you've looked at your organization and your assets, and you've decided you want to build a digital twin. Well, what next? Well, the first step is often to assess, where are you right now? What stage is your organization in? What's your organization's level of data maturity? Many organizations that look at this are really in stage 1 and 2, but they would like to get to stage 3 and 4, with 5 being the ideal vision for most. And kind of a brief summary of each is that 1 is very much kind of the lowest level where your data is held at the project level. So if someone comes in and replaces a bunch of assets and does work, that data may be captured, but it may be constrained to that one individual project. It's not shared across time, so that 3 years later, when you're looking at, say, a water network and you're trying to learn information, you may have the location of those, say, new pipes and infrastructure that was installed, but you may not have any of the additional attribute information that was captured at the install. You may not have as-builts readily available. You may not have actual attribute information for those individual assets. It's all locked down in that individual project level. Stage 2, you start seeing some integrations between those, but you're still kind of locked in kind of that legacy third-party application. You're not really at an enterprise level yet, but you're beginning to grow towards it. In stage 3, these are really the organizations that are much more primed to begin building a digital twin, or at least moving very closely towards one, where you do have enterprise asset management systems, project management systems, BIM, GIS. And so you have these various systems that are storing your data. They're storing it across projects, across time, but they still are pretty siloed. They don't really speak to each other. You have to export from one in order to get into another. It becomes out of date very quickly. And so that's where the digital twin really comes in between steps 3 and 4, where you start integrating these various systems together, where all of a sudden, your BIM is actually being integrated with your GIS so that you can see one and another. And more importantly, you can see all of them together in your digital twin platform. You're still at this stage at kind of your basic level of integration. You may only have read access to these data sets. It may still be some challenges involved with getting that data to sync together, but you're beginning, really the final stages of your process where you can start working towards stage 5. And that's where you have your digital twin is fully integrated. You might actually have read-write access across these data sets so that people with the right permissions, can not only make an edit, let's say in GIS, and see that represented in your digital twin, you also might be able to do it vice versa, where you have a manager make an update in the digital twin, and that can cascade down to those other systems so that those individual departments can also see that information. And this is where we're also fully utilizing the Internet of Things, or IoT sensors, and you may begin to be looking at more mature uses of, say, machine learning to do real-time and predictive analytics once you have enough data collected to really begin training that type of tool. Oh, and last on that is that there are organizations like the Institute of Asset Management, or IAM, that do offer things like a self-assessment tool. Other organizations can help you with this as well, as the Digital Twin Consortium, figure out where you are on this graph. However, we have found that most organizations, once they have this laid out in front of them, they have a pretty good feeling of kind of where they are based on their current data sets and their current systems. But the next step on thinking about your digital twin journey is aligning your resources. And so that is, first of all, by definition, a digital twin tends to be multidiscipline, which means it needs a multidisciplinary team to build and manage them. So this means you don't only need, say, a BIM modeler, you may also need a GIS specialist, you may need data analysts or IoT and integration specialists, your asset manager involved. Because you have so many different disciplines working together to essentially feed and maintain your twin, it's likely to be an endeavor that takes people with either multidisciplinary experience or multiple people from different departments working together. And in that vein, if your facility is large, your managed assets are large with many different departments and sources of data, getting buy-in early is absolutely critical. You have many departments where they are storing their own data, they're maintaining it, they're updating it, and you might have a desperate need for that data in order to build your twin and really make use of it in the way that you want. Well, you're going to need buy-in from these departments in order to really work with them. And while you could just go to them and spout or talk about all the great things that digital twins can do and why they should get on board, I strongly encourage you to, while you can do that, to also really focus on listening to them. So go meet with the various departments and listen to what are their pain points. What are the things that they struggle to do, where they have data that they think exists but they can't access, or it's very laborious to access? Workflows of theirs that seem very inefficient, or that it's difficult to get done. If you would listen to the managers and the personnel in these departments, you listen to their issues. A digital twin is not going to solve every issue of every department, but you will almost certainly find some issues that these departments are facing that your digital twin can help with. And if you listen to them tell you their problems, and then you come back with a solution and say, this is why the digital twin initiative will help you, you're much more likely to get buy-in from these folks. And ideally, to identify representatives from each of these departments, or even companies and vendors that you may be working with across your across your organization, to be your primary points of contact. And you're going to need these type of people to help assemble people and data when needed. When you're at the stage where you really need to start getting data from them, you don't want to spend weeks going back and forth with email. You want to have someone there who understands what you're doing, what you need, and can help you get it. Ideally, a champion, someone who really believes in what you're doing and supports it. And related to that, identifying those goals is to think about, what is your actual budget and what is your schedule, that you have available to do this. Digital twins are not a 1 to 2 month endeavor. This is not something you're going to decide to do in August and finish by October. You may have milestones, but the actual endeavor is certainly to get to like a stage 5 digital twin is likely a years-long endeavor, especially at a larger organization. And so instead of just focusing on that, grand goal at the end of the road and just kind of putting your head down and working towards it, that can be difficult. Budgets are not always set in stone. Schedules can change. And so you want to make sure that you identify some early wins. What are the low-hanging fruit that you can identify and identify as early milestones that you can work towards first? Because if you, in a matter of months can turn around and provide a real benefit to some departments, you're much more likely to be able to not only build support, but start building momentum for your initiatives, to start growing it so that you can work towards bigger and better things. And many of these are covered in the idea of change management. And I would encourage you, if you're looking to adopt a digital twin platform, to adopt a change management plan along with that. Next really important thing that I think is maybe sometimes overlooked is the importance of preparing your data. It may show the nerd in me, but it's something I get a little excited about because it's just such kind of a detail-oriented but critically important part of any digital twin. And that is to say that all the fancy digital twin software won't help you if you don't have acceptable data to build that digital twin. And so by their nature, digital twins pull from different sources of data. You're pulling from BIM, whether that be Revit or Navisworks or Construction Cloud. You're pulling from GIS. You're pulling from asset management systems, various individual vendor systems, as-built and riser diagrams that may or may not be digitized, let alone put into a system like GIS. And so you're going to have to think about how you're going to actually integrate and digest these various sources of data. And if these systems don't utilize a shared ID, the twin can't really connect them. And so that very simple example on the bottom left of 4 different air handling units, human eyes like ours can look at that. And after you look over the 4 of them, you can probably say, I think these are all 4 of these are the same asset. One is a leading 0, one is a dot, one is a dash. It's just different systems calling the same thing something slightly different. Well, your digital twin isn't going to know that. And while AI has made leaps and bounds, I wouldn't hold your breath for AI to just solve all of your data problems for you right out the bat, or right out the gate. And so this is the type of work that it takes time to really figure out these connections between systems. What does GIS call this? What does this vendor system call it? What does Hexagon call it? Understanding what these various systems call assets and what their ID formats are is really critical to being able to merge them together, since really the whole point is to be able to draw your various sources of data together to draw holistic solutions. And you need them to connect to each other in order to do that. And that takes time. You don't want to assume that you'll just get all your data and in a month you'll have it all merged together and thrown into your digital twin. If it is, I'm very happy for you. But you need to assess your data first to understand what is the work that is going to be required in order to build this twin and to connect these data sources together. Because twins, not only do you have to connect the same asset together across various systems, as I said earlier, twins rely on relationships between assets. And so where are those relationships stored? Once again, if they're stored on PDF or even paper diagrams and line diagrams in a file cabinet, if that's the only source of that information, someone's essentially going to have to go digitize that information. And you have to account for that. There's going to be a lot of value from doing that. I encourage you to utilize that data, but you have to understand what it's going to take to be able to do so. And last, I don't tend to highlight individual software necessarily in these, but FME Workbench is really an incredibly valuable tool when you're dealing with these early stages of assessing, preparing, and merging your data. There are other options available, but it's one of these softwares that's very good at taking data from CAD, data from GIS, data from your asset management system in almost whatever format they export in or store their data in, and working with it in a way that you can start making sense of it. And that's what this relatively simple diagram on the upper left shows, is that you're taking 4 different exports from Navisworks, you're filtering them, joining them together, and essentially creating an export that you can then use in your digital twin, with these different sets of data merged together and filtered as needed. And related to that is the idea of collecting your 3D data. So most people who build a digital twin want some kind of digital representation of it. It doesn't have to be 3D, though often it is these days. And so whether that's point clouds, whether that's imagery, whether that's a BIM model, it is an undertaking to capture these. And you have to think about, how do you want to do that? Well, it depends on what type of assets you're talking about. If you're talking about very spread out assets, say pipelines, then you might be looking at, drone or airplane based scanning, versus if you're dealing with an airport or a factory, you might be looking at handheld or terrestrial LiDAR scanners. But it is important to note that a lot of people get very excited about these because they are intrinsically cool, to go scan your site, and especially if it's colorized, to see these kind of colorized point clouds, these 3D models of your site. But that in and of itself, kind of going back to the beginning of the presentation of what is not a digital twin, that may not get you where you want to go on its own. And you have to be prepared for the idea that if you have that, you then have to actually populate that information with your attributes. And if you have all of that information sketched out in, say, diagrams and CAD and such, it may still take some time to put that into the BIM model that you're building, if that's what you're building from your scans. But if you don't have that information, you could, at the end of the day, end up with a pretty picture or a pretty model that doesn't actually have any attribute information you can use within it. And no attributes, and especially no IDs, mean you can't really integrate that with anything. And so it just kind of stands as a 3D representation of what you're looking at without actually identifying what the individual features are. And the work required to populate that, once again, if you have that information, in diagrams, in databases, you can do the work to populate that. But if you don't, you should consider, what it's going to take to do that. I don't assume, unless it's been promised to you by the provider, that your scans are going to be detailed enough or high enough resolution to read, say, asset tags with asset information on them, for your pump, for your remediation equipment, for your air handler. You may have to have someone essentially doing a survey, going out in the field and collecting that information on those assets. At the very least, the ID that you can then use to connect it to other systems of record. And there's a lot of tools for that, but I do encourage you to ideally use one where you can edit your model or edit your GIS, if that's what your data is based on, directly, rather than surveying it separately, which still gives you the extra task of trying to figure out how to actually populate that into your model. So the next step, you've assessed your data, you've potentially collected more information or more data, you've assessed your current status, is to select a platform. There are many options, and I'm not here to advertise one over another to you. You should really assess the options that are out there and select the one that best matches your business needs. And so you have type of asset to be twinned? Well, are you dealing with a wide spatial area? Once again, are you dealing with a wastewater network, water utility network that's spread out over a very wide area? You might be thinking about a twin that's more GIS centric, versus if you're dealing with complex vertical architecture, maybe you want to think about a more BIM centric twin. Many providers can do both, but we found it's unlikely that you have a provider who is really equivalent between the two, that you generally have them focus more on one than the other, and then they integrate the one that is kind of less of the central focus. So selecting what's appropriate for your business need. What has potentially existing integrations with providers or systems you already use? So most providers are willing to look into ways to integrate with a system if it's critical to you, but you're going to save yourself some time and effort if you happen to select a provider that already has existing integrations or relationships with the provider you have. An integration example would be that one of our clients uses Matterport and really likes the output that they get from Matterport, and they want to integrate it into their twin. And so your digital twin provider can work towards that, but once again, it would be easier if they have an existing relationship with Matterport rather than you essentially getting that integration on their roadmap to be built at some point in the future. And last is the existing provider / experience. What is your team's experience with these providers? Is it a provider you already work with for other work that also offers a digital twin solution? Or is it something where you have a very GIS-centric digital twin that works very closely with your GIS provider, and you have two teams in-house. You have a GIS team with 40 people, and you have a BIM team with 8 people. Well, you may consider leaning towards the one that has the closer GIS integration, given that your staff and your personnel likely have more experience and familiarity with the type of software being used, and especially if it's with that particular provider. Then you have to think about how you're actually going to implement it. Who's going to do the work? These are labor-intensive tasks to put together. And if you don't have the internal bench strength or experience to deploy your own digital twin, you have to decide who will do it, with you. Your two primary options are really the software provider of the actual digital twin or an AEC or consulting firm. And there's pluses and minuses to both. So the actual software provider, not all, but many digital twin providers have an implementation team. So a team that focuses on not just kind of the development of the digital twin like the software team does, but also helps clients implement them. The benefits of this is that they are very likely to be very familiar with their software. It is their company. And with that, they may have a much closer connection to their development team. You are relatively unlikely to find, especially because digital twins are a very fast growing business. It's unlikely you're going to find a provider that has every need that you could have already deployed out of the box. Very likely you will run into something at some point, whether it's an integration, whether it's a feature or a way of viewing your data that isn't built in. And so if you work directly with the software provider, they're likely to have a closer relationship with their own internal development teams and may have a better chance of getting that put on their development roadmap so that you may be able to get those capabilities added sooner. However, some of the software providers, they may have less project management experience. They may have less experience delivering projects for clients like you, and they may lack institutional or design knowledge of your particular industry. So they may be very skilled in the software they do, but they may not be very familiar with kind of the mechanical or technical needs of your industry. And that's where someone like an AEC firm or consultancy may come in, where they, on the flip side, may have extensive project management experience. You may have an existing relationship with one of these firms that you can leverage, where they already know who you are, they know your teams, they know your needs, and they can often bring diverse institutional knowledge as well. So one of these firms may work with not only you and not only other clients in your industry, they may work across industries. And while the needs and requirements of those other industries may not perfectly match yours, they may bring ideas and solutions from these other clients that could benefit you as well. But of course, the drawbacks is that have to think about what is their familiarity with the software provider that you selected. If it's limited, they will be on a learning curve. Even if they bring the best people, they'll still have to learn the software and work with the provider. And they can be one more step removed from the development team. Doesn't mean they can't get things added to the development roadmap, but they're not necessarily sitting in the same office in the way that the software provider implementation team might be. And last on that, I just wanted to share some basically overarching tips, tricks, and hurdles that we've run into in our digital twin work here at Parsons. First is really emphasizing the need to identify use cases and early wins. And this doesn't just mean identifying use cases, but maybe identifying the things that don't have an immediate use case. So some clients get bogged down in ordering, say, laser scans, building very pretty visual models of their site, but they could, at the end of the day, realize that while they may have a pretty model, they may not actually have a lot of direct application of that model. And so, we've had clients spend, over a year trying to find missing assets, update their models. And yet, one of our clients, one of their first wins was identifying, in this case, it was an airport, identifying wasteful usage of airplane fuel, basically airplanes that came up to the gate and that weren't connecting to ground power, or at least not early enough. So they're essentially sitting there burning fuel when they could just be connected to the ground power. And this not only represents a waste in fuel, it's certainly a waste in cost, but also has an impact on their emissions goals. And so this solution, or this identification, didn't really require any modeling, didn't require any visualization. It just required setting these sensors up, and yet they represented a substantial cost savings for that client. So identifying those use cases early and identifying what you should prioritize is really key because the digital twin space is so big. There's so many directions you could go. The next is the idea of aligning your sources of data early. And so I talked obviously some about the importance of data and the importance of connecting your data together, but also something that may sound as simple as making sure you're getting the complete data set or that you're getting the right data set. And this is where that communication with other departments and providers comes in. You don't want to be in the case of asking for data and they provide it with the best intentions. And then 4 months of integration work later, you find gaps in your twin. And you may realize that, the department who gave you the data had a filter set, on the data they sent you, or they didn't realize the types of data that you really needed. They may have had attributes left off, whole categories of assets that they didn't give you. And that can represent a lot of rework. Where you already have done a lot of that integration work and you essentially have to grab this new bucket of assets and start over again. And so you really having those lines of communication open early, being very clear about what it is you're asking for, why you need it, what you're using it for, can really help them understand what you need. And so that you make sure that, when you're integrating with these different data sources or getting exports from them, that you get the data you need the first time and not, months later. And really the absolute importance of recruiting champions and representatives early. Digital twins take a village to thrive because they're so multidisciplinary, because they pull from so many different sources. It is very likely that you are going to, even if you have a small core team actually developing and building the twin, that you will need participation from many others. And so identifying those resources early, identifying those people, getting their buy-in, showing them the benefits that how it will directly benefit them to get them on board is really critical. And lastly, the idea of knowing what's next. The sky is kind of the limit when it comes to a full digital twin implementation. As I said, there's so many places to go with it. And so often you're identifying one or two, early milestones that you can work towards. And while that's critical, it is very useful to keep in mind, what is your roadmap after those? What is your milestone 3, 4, 5? Because you can potentially start building the data you need, start assembling the necessary resources early. So if you go to a department and you ask for data that you need for milestone 1, if you already know that you're going to need, a bunch of additional data from that department, 5 months later, if you can get that now or get the ball rolling on that now, that can really help so that you don't want to be in the situation of achieving a milestone, getting a goal, everyone's really happy, And then you're kind of starting from scratch again when you go to the next, endeavor. Ideally, you want to already have made some progress towards that because you've been doing, very similar work. And so understanding, is that additional IoT integrations? Is that forecasting, especially because those lines of communication can sometimes take some time to develop? It's important to start thinking about that early while you work on some of those earlier milestones. And so summarizing, what did we learn today? We learned what is and isn't a digital twin. Why should you build a digital twin? The importance of aligning your resources to support your deployment. The importance of preparing your data, cannot stress enough. That diagram on the left is a much more convoluted and complex version of a FME diagram like I showed earlier, but nonetheless absolutely critical for what we were doing, where we took one large data set of hundreds of thousands of assets, and we broke it apart into all of its various types of data and then filtered that down. And basically, because you don't really want to load just a kitchen sink of 800,000 assets, into your system without really knowing how you're going to use them and how they're going to integrate with others. And so preparing your data, understanding your data, and collecting your data that you have missing that you need early is really critical. We talked about how to select a platform and some considerations for that. Considerations for selecting an implementer, who's going to build your digital twin. And last, some tips, tricks, and hurdles that we here at Parsons have run into in our digital twin work that we hope can help you. And with that, I'd like to thank all of you for your attention, and I'll be happy to answer any questions you have.
Thank you, Tim. That was a really great presentation on what digital twins are and how they can be used to optimize and improve operations. And like you said, document critical information so it's not in a few key people's heads. If there's any questions, you can either raise your hand and we'll call on you and unmute you so you can ask it live, or you can enter it into the chat and we'll read it out. Let me go back to the top. So there's some good discussion going back and forth, but I guess give you a chance to give some input on these. Can a digital twin be implemented on the city level?
So yes, of course, the larger your asset and certainly the more assets that you're dealing with, the bigger the endeavor. But the same idea applies, as I was just describing, is that you identify some of those early wins that you can do and start building the momentum of what. So you might start with, say, just your irrigation system. We were in talks with a city in the Middle East on, building a digital twin of the irrigation system to understand how their water is being used across the city, where it's going, where it's not going, and identifying gaps where water is unaccounted for. And that alone is a pretty big endeavor, certainly involving the irrigation as well. But that's kind of one section to start with, and then you can start building from there. And so you start building the foundation of your twin, and then you keep adding disciplines or areas. I'd encourage you not to try and start with, the whole world all at once, because you'll kind of drown in the amount of data that you're looking at. But, Toronto is maybe another example where, they have, a very visual focused digital twin for the public that really is kind of high level and focuses on, weather sensors, showing subways, highways, just kind of showing the location of things. But they're picking kind of where they start, and then they can begin or continue growing from there.
Next question is, what are my options for scanning or creating 3D representations of my assets for a digital twin?
So it really depends on what type of asset or what type of assets, I should say, that you're managing. So, if you have very spread out assets, you may be looking at something like drone-based LiDAR or imagery. If you're dealing with a lot of underground or internal or complex vertical architecture on the interiors, you may be looking at scanning internally. And, once again, you can have terrestrial as kind of you can do, if you don't need very high resolution, you can potentially save some money using, say, a handheld scanner. and kind of walking your area. And because if a moderate level of resolution and an approximate location is good enough for your needs, if you don't need to know where things are within, a quarter of a centimeter or half a centimeter, and you just need to know, I know this air handling unit is in this room and it connects to these, fan power boxes. Something like a handheld scanner may help you with that, as opposed to dealing with kind of more tripod style traditional LiDAR scanners. But in both cases, I really stress to think about the outliers, the things that you're not going to capture. So, do you have assets that are above ceiling tiles, or that are very difficult to reach in locked rooms or in sub basements that are going to be difficult to capture? You want to make sure you have a plan for capturing those. And then also the idea of capturing the actual asset information, at the very least a tag number or the ID of these assets when you're doing your scan. Because often the kind of the simple 3D LiDAR or visual scan isn't going to give you enough resolution to do that unless you make a point of standing right in front of the asset tag. So you can either do that, or you can go up to these asset tags and kind of snap a picture with that same device if it's capable, so that you can then go back in later and kind of populate those. Just really important things to consider so that you don't end up with, you don't want to spend months getting a scan done and then spending the time to have that turn into, say, a BIM model, only to find out that you missed 30% of your infrastructure that you really care about, or that you don't have the actual attribute information for those assets that you need to actually make use of it in your twin.
Okay, next question we have in the chat is, if you are preparing a BIM strategy document for a client and their desired use cases, what are the key points to consider when preparing that document?
So can you repeat the beginning of that one?
So when preparing a BIM strategy document for a client for specific use cases, what are the key points that should be included in that strategy document?
I think it's to ensure that you have standards set in that document that are going to meet your needs. So there's a lot of ISO and other standards out there that you could just throw at the wall and just say, okay, that's what we need. We'll just match that, without really understanding, what are your particular needs. They may be met by those, but they may not be, and you may be doing kind of an unnecessary level of work to, say, collect a lot of information or a lot of metadata that you don't really need. And so I often come back to, what are your actual client needs? What are your facility needs? It doesn't mean you shouldn't go beyond those, because it's hard to anticipate all the needs, say, years into the future. But really starting with that as a base level of what is the information that they actually need to build this twin or to do their work, and then making sure, and then going out and finding kind of the standards and procedures that will meet those needs, rather than just kind of starting from the procedures and then kind of working backwards and assuming that they'll meet your needs. But my background is mostly in GIS. But when I came to the digital twin world, we have other people on our team who are quite the opposite and come from the BIM world. So I'd be happy to follow up with that as well.
Okay, next question is, you mentioned the digitizing of paper and PDF documents as part of the initial process. Where would you recommend a client with mostly paper and PDF records start if they want to work towards building a digital twin?
So it really is. I mean, it's not necessarily the happiest answer or the most exciting answer, but if most of your data is locked down in PDFs, is locked down in paper, you should really start thinking about how to get that into a more usable format, whether that's GIS, whether that's CAD, whatever it may be. Getting that into a format that's going to be usable and digestible by a digital twin is really critical. But the one advantage you have is that if your eye is already on a digital twin, even though you're maybe at that kind of stage 1, stage 2 level, is that you can figure out what is the information I'm going to need, and more importantly, what format am I going to need this in, that's going to be most usable for my digital twin, and then start working towards that. Rather than, say, just digitizing everything and then finding out that the format that you've turned it into is very labor intensive or not very usable to a twin. But you could, the one other thing to consider is that, depending on how many you have, how difficult it is, the resolution of them, if they're kind of I used to work for a large facility that was under 6 feet of water during Sandy here in New Jersey. So a lot of their records were not very usable after that. You can essentially start thinking about how to start collecting that information new, especially if you've had updates to your system since then, because that's the one thing is that while a lot of that information may be valuable, you don't necessarily want to spend months and months digitizing data if only say 40% of it is still up to date. And so I encourage you not to throw it out, certainly, but if you get to a point where you realize that this data isn't very up to date anymore, that you're likely going to have to do a scan anyway, depending on the quality, depending on the amount, it may actually be worth essentially starting over again. If you're going to have to do a scan and a survey anyway, maybe you just do the whole thing. Would be the one other option.
Okay, next question is, have you seen AI being utilized for object extraction and or populating model attributes once you've scanned your assets?
So I haven't seen it yet personally, I haven't seen it yet for populating the actual attribute information from the scans. I don't see why that wouldn't be a direction that a lot of these companies would go. We've all seen the ability of AI to read language quite well in imagery, even to the point of doing it live as you move a camera around. I'd still go back to the caveat from before, though, of making sure that you don't want to just assume that you're just going to throw AI at a problem and it'll go away. And if you have your scans done and then the AI can't collect enough information from the scans simply because, say, the resolution isn't high enough, or some of the asset tags were, smudged or something and difficult to read, you don't want to be in a situation of doing that whole scan and then realizing that you only have asset information for about half of them, and then you have to go back out after spending all that time trying to do it the first time. In terms of object identification, that's something I've seen a little bit more on the drone side. I'm sure it's being done on the terrestrial side as well, but just my own experience on the drone side. You're still often with, certainly with machine learning, but even with AI, you're kind of relying on someone to have either built a tool or you'd have enough data to train these tools to then do their job effectively. And so if you're trying to, it's not exactly digital twin, but if you're trying to, capture parking lines on large parking lots across, thousands of properties, say from satellite or airplane or drone imagery, if you have a company who's specialized in exactly that, or maybe Cracks is maybe a better example, and you have a company that's been training an AI or been training a machine learning algorithm to identify cracks in similar types of conditions, then that can be really powerful. But the main worry about these is that you're just going to take a machine learning algorithm and just throw it at the problem. And if you don't have enough training data to train it on, you may not be satisfied with the results. The example that a colleague of mine used was, it's like a baby, like machine learning, where you have to train them on a lot of data. And if you have a lot of data, that's fantastic. But if you don't, and you're expecting just to sit them in front of a problem for them to figure it out on your actual data, you may not have a lot of success doing that.
Looks like I got one more question in the chat so far. Is the digital twin a one-way communication platform, or can it do some operation calculations to perform a potential action based on the collected information, like open a gate?
Yeah, so that's really where I would see that between the stage 4 and 5 of maturity of your system and of your digital twin, is that by far most digital twin deployments are going to start with essentially just that read access, where they're just taking information from your GIS, from your BIM, from your vendor systems, and they're just digesting it and giving it to you in a single pane of glass that you can use for decision making, that you can see how they relate to each other, to draw new conclusions from it. But you're often not saying, therefore, turn off that air handling unit, or that smart glass, dim all that smart glass in that terminal based on this control in the digital twin. However, this doesn't mean to say that you can't work towards that. And that's where you're getting to a stage 5 level of maturity, where you have that kind of two-way street between the digital twin and these various systems, where you're unlikely to get to a point in the near future where the systems aren't managing themselves somewhat, or edits and changes aren't being done in the various kind of department systems of record, but where you could have the ability to write and change things from the digital twin and have that go back to either do something physical, you said, like closing a gate, or at the very least kind of write data back to the other one, so that the systems can be kept up to date, and that the person who sees something wrong in a digital twin or something that's outdated, they don't then have to go to that other system to update it. They could just update it right there. The only once again, the less fun worry about that is permissions. And that's always the case, is that you want to be sure that your system is set up in such a way where digital twins, at least some parts of them, are made for the non-technical folks, so that they, the decision makers and the managers who are actually using that data to make decisions, but you want to be sure that they understand what they're doing, if they do have that right access, and to constrain those permissions so that you don't have your data essentially being improperly polluted or edited in ways that it shouldn't be, just because you've given right permissions. And you'll find many vendor systems are for that reason, very hesitant to give right permission, but with the right coordination, the right permissions, I don't see any reason why that couldn't be done.
Okay, well, it looks like that might be it for questions. If we can go to the next slide. So our next webinar will be on September 13th, the same time, presented by Ron Crosscheck and Sam Kermis on drones for orphan wells, applying modern solutions to a century-old problem. So I really hope you can join us for that. The link to the Professional Development Hour credit form has been posted in the chat. If you miss any of the questions or the content that you would need to answer those questions, a recording of this webinar will be posted soon. Thank you again to everybody who joined us today. We really hope to see you next month in September.